Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who obviously has been the greatest living philosopher before me. Now, with regards to this video, you probably are already outraged, by its title. Like, you might say, like, wait a minute, Eugene, I thought we were dealing with some, serious philosophy here. So why are you trying to sell us these, cheap titles like 7 this, 15 that, and whatever the hell it is? And you would be absolutely right. Like, I would agree that only a complete idiot would click on that video, and only an absolute moron could have created such a video in the first place. I'm not sure about the first one, but the second one is definitely correct, in this case at least. So anyway, that way or another, we're going to be talking about Copernicus. Yay! I know, please relax. So obviously, the whole topic of Copernicus has become somewhat, trivial, I guess, somewhat too popular. It's like a philosophical fast food, basically. So you can walk to any philosopher of science and say, like, wait a minute, guy, let's talk about the development of science, let's talk about scientific revolutions. And he would immediately, sit back and draw his pipe and start chewing on it and say, Copernicus, right? Or imagine you're at some scientific conference or something, and they just to relax people, they've put, in the last talk before the banquet, they put a talk on philosophy of physics, let's say, or astronomy or science in general, whatever, and they've invited some philosopher of science. And I almost guarantee you that if he wouldn't be talking about the Copernicus in the first place, 100% somebody in the audience would modestly raise hand and what about Copernicus, or something to that effect. So it's in my opinion, it's like philosophical fast food, this whole topic of Copernican revolution and things like that. So that's exactly why we're talking about it, right? Although I would say that I would pretty much like if somebody came and somebody smart, preferably smarter than me, come and kind of deconstruct this whole myth of Copernican revolution and things like that, because I believe there's a lot to talk about here. There are a lot of really suspicious things going on, a lot of propaganda, definitely, a lot of mythology, if you like. Well, I'm not sure if you're aware of my viewpoint in general. Like I have this stance that basically I'm super skeptical about basically any history, at least with regards to dates, before 17th century. 16th century is already a fairy tale, if you ask me. I'm not even talking about the fact that our historical timeline was established more or less in 16th century or about so, or perhaps even in the beginning of the 17th. But that's a separate discussion. So I wouldn't even try to get into these swamps, so to speak. I'll just note literally maybe one consideration here. For example, it's considered that Copernicus, if he even existed again, given my skepticism, it is considered that he's a Polish guy. He was from Poland, right? From the town called Toruń. And the Polish consider him almost like a national hero. There's everything in the name of Copernicus and so on and so forth. But I have serious doubts that he was from Poland, actually. Well, again, in the first place, I have serious doubts that he even existed. But even if he existed, he was probably not from Poland, in my opinion. So, for example, if you look at his book, what he writes there, how he calls himself, he writes there Nikolai Copernicus. Well, let's suppose that is true. Torinensis, which means he's from some place called Torino, which in my opinion would indicate the Italian city of Torino rather than some backwater village in Poland. called Torun. In fact, like some serious astronomical tables were constructed in Italian Torino, and so I wouldn't see it as impossible if whoever the heck that guy was actually, you know, working there rather than in Poland or something. But anyway, that's again this whole deconstruction, you know, narrative. But you know, we're doing stuff cheap here, so why don't we start from this, you know, regular myth about the Copernican revolution, that apparently there were really stupid people who used the geocentric model, and then there appeared really smart people like Copernicus and Kepler and Galileo and others who started to use a heliocentric model instead, and they were the geniuses, you know, they were the revolutionaries and so on and so forth. This story that we all know and love so much. So, and here comes my 7 lessons, I guess, from Copernican revolution. So I would say that the first lesson that we should learn from it, I mean from this fast food kind of myth that we're fed, is that Copernicus wasn't even the first guy who invented again, Copernicus, you know, who invented this heliocentric model, right? Because there was this Greek man, Aristarchus of Samos, who apparently, I mean, according to our current timeline, developed the same idea like 17 centuries before Copernicus. So that's quite a lot, you know. So, and with regards to that, like what lesson we might extract from that, I would say that it is the fact that not only the idea matters, you know, but the support of this idea from various, you know, like political ensembles, from the current state of affairs, so to speak. Like, you know, all these examples, like for example, paper and gunpowder and a whole lot of other things were apparently, supposedly developed in China, but they weren't used there to that, you know, at that scale as they were used later in Europe, exactly because in China there weren't so many, I mean, even if you suppose that they were really developed there, or, you know, invented there or whatever, there was just no support from these political ensembles, from the society wasn't really ready in some sense to use them productively as people did in Europe later. So I think this is exactly the case with our, you know, inventor of heliocentrism, like 17 centuries before Copernicus, who is basically unknown, whereas Copernicus is praised as this, you know, like almost like a half god or something. Especially again, if you talk to a Polish guy, he would say like, oh, Copernicus, like, oh, or something like that. Like, no offense, guys, like, jeszcze Polska nie zginęła. All right, so and if we're talking about again politics and these societal ensembles, how they are organized, we'll definitely talk about that sometime later also, because this is a really important topic. But with regards to this particular subtopic, so to speak, I should say that indeed, like, if you have allies, political allies like Galileo, like Kepler, and so on and so forth, who were exactly saying that they base their ideas on Copernicus, well then you're gonna be a pretty successful guy, apparently. Like for example, if we're talking about Kepler, like for example, just one of his friends was the one Albrecht von Waldstein, who was none other than the leader of the army of the Roman Empire. And, you know, with friends like that, I mean, your position in any argument would be pretty solid. So you can promote any kind of ideas you want, basically. And that's pretty much my point. Like, nobody cares about Aristarchus of Samos. I mean, who cares about them? But everybody cares about Copernicus because he had all these friends, like, again, Galileo, Kepler, and so on and so forth. All right, that was the first lesson, that politics matters, that the society matters, and it's not just the idea itself that gets accepted or, you know, declined by society, but it's the supporters of this idea that matters first and foremost. And even the most stupid ideas might be accepted, and even the most brightest ideas might be, you know, thrown away if they don't have significant political support. Okay, so second lesson, I guess, from Copernican revolution would be the fact that Ptolemaic system, this geocentric system with epicycles and stuff, it was actually even more precise. It was better in practical terms for like at least maybe a couple of centuries after the invention of the heliocentric model by Copernicus. Oh, by the way, let's kind of rewind a little bit. I wanted to add here also that again, kind of returning to my point about, you know, historical revisionism and stuff, that maybe it's the problem is that this Aristarchos of Samos was invented sometime later, already after Copernicus, or maybe at roughly the same time or so, you know. But that's, you know, maybe that would be too hard. So let's skip that point for now. So the second lesson is that Ptolemaic system was actually more precise than the Copernican heliocentric model, and it was used even a couple of centuries after, you know, even basically in 18th century, let's say, for navigation and things like that. Maybe it's because, you know, sailors are pretty superstitious, they're pretty, you know, traditional people or something like that. I don't really know. But I would guess that perhaps one of the reasons was that it really worked. So for you know, regular public, it doesn't really matter what kind of theory you have on a theoretical level. I mean, like how elegant it is and so on. What matters for them is just whether it works or not. And if something old works, then why substitute it with something new? Which is, you know, it's always a risk and so on. So why fix something that works, right? Even though it's pretty complex and so on and so forth. So, and I believe the lesson that we should learn here is that, well, you know, frequently, like if some alternative scientist comes along right now and says like, oh, look at that, I have this idea, I have this theory and so on. And somebody would say, well, wait a minute, our old model gives much better precision, so what would you say about that? And you say, well, what this alternative scientist says, well, I don't know, like, well, apparently, like, my model is much more elegant than yours, but unfortunately, yeah, you're probably correct, my model doesn't give you such a good precision and so on. But you see, the point is that the more effort you spend basically on development of the model, the better precision you would get. Like really, like it's just that Ptolemaic system was around for such a long time that people have kind of invented ways of overcoming its inherent problems. Let's put it that way. And obviously, like if you look at modern, like most fundamental theories, like standard model in particle physics, for example, which has like how many, like 26 free parameters or something like that, or Big Bang cosmology that has like 17 parameters or even more. Like, you know, like as Archimedes said, you give me 17 parameters and I'll fit any function you like. So, and that actually relates to the third lesson that we should learn here, in my opinion, which is that basically Ptolemaic system was probably the first occasion of the use of Fourier expansion, right? So, in case you don't know what it is, we have some periodic function, and we can just algebraically substitute this function with an infinite series of periodic terms, right? So that's exactly what those epicycles were. But people only noticed that in late 19th century or about so, kind of again, it kind of relates to this previous point that with enough complexity, you can basically fit any kind of data that you want, right? So it's no wonder that, you know, standard model explains everything when it has like 26 or even more free parameters. Like it's not a big miracle. That's what I'm saying. But at the same time, the lesson that we should learn here, I believe, is that even retarded ideas, even stupid theories, like for example, it's not really stupid, but it's kind of is, right? The Ptolemaic geocentric system. Like, we can learn something even from those kind of ideas if we look at them, you know, like real close. So, for example, we could have gotten this idea of Fourier transformation much earlier than we did if we paid more attention to the previous theory and kind of, you know, tried to condense it into something meaningful. All right. I guess that was the third lesson. And the fourth lesson, I believe, is that, well, Copernicus, whoever that was, if he even was in the first place, as you probably know, he wasn't really punished for his, you know, crimes against church and so on. So his model was kind of modest in some sense. It wasn't that blasphemous. All right. Well, at least he lived, or maybe he didn't. Maybe he didn't exist in the first place, which would explain why he wasn't punished, because you can't punish somebody who doesn't exist, right? Although, you know, all these tales about Xerxes, the Persian king who was ordered his men to slap a sea or something, like punish the sea gods or something. Well, good luck with that. Well, maybe, you know, the church should have burnt the like the puppet of Copernicus or something like that. But I don't know. Digression, sorry. So the point is, Copernicus wasn't really punished because his ideas weren't that, you know, radical, if you like. But there were people who were punished for these ideas, and one such person was Giordano Bruno, who actually said that not only is Earth turning, like orbiting the sun, basically the Copernican model states that the sun is at the center of the universe and everything else revolves around it, right? But what Bruno said was that the sun isn't even the center of the universe, but there are infinitely many suns like our sun, and there are infinitely many planets around those suns, and so on and so forth. This is pretty much the same idea that Epicurus was promoting in ancient Greece, and so on. So, like today, we know that Bruno is actually correct, right? Like, we have infinitely many, well, maybe not infinitely, but many stars, and we have many planets, and so on and so forth around them, around those super distant stars. So Copernicus wasn't punished for his ideas, but Bruno was. He actually was burnt at the stake, believe it or not. And I don't mean, like, you know, the stake in the sense that they've had a barbecue party and you know, these cardinals kind of invited Bruno, like, hey, Giordano, tu vuoi eat some steak? And they, you know, give him the plate, and he accidentally, like, burned himself with this steak or something. He was actually burnt at the stake, like I guess he was the stake of that day or something. Like, well, okay, the point is that the lesson that we should learn from here is that you probably shouldn't be too revolutionary, you know, for your time, because well, I mean, compare those fates of Copernicus and Bruno and you would see why, right? Even if you would be right, there might be some serious consequences for you. And I mean, maybe you want to die like a martyr. I don't know, why not? Some people do that. So, but that's ultimately your choice. But you have to keep that idea in mind, that to go too far outside the accepted narrative is dangerous for your health. Let's put it that way. All right. So I guess the sixth lesson from this whole Copernican revolution thing might be the importance of like the level of development of society, in the sense that, again, kind of returning to this topic of political ensembles. But here I want to say about the means of communication. Like, I strongly believe that one of the things that made possible this Copernican revolution was the printing, the book printing, right? Because Copernicus might have had an opportunity to easily kind of spread his ideas out, because he could have just printed a book, right? Whereas like a couple of centuries before him, you couldn't do that, right? You just didn't have the instruments to spread the information out as quickly as you could later. And not only the speed what matters, but also the fact that, like, let's say if only monks control the printing of books, like printing, I mean, they're just literally writing them, then they wouldn't write your book if you're not supported by church, right? So there's this kind of a system of not allowing people to spread knowledge, even if they really want to, but if the system that distributes the knowledge disagrees, right? And I believe that the lesson that we should learn here is really relevant for our current era, and in particular with the advent of the internet. What I mean here is that I strongly believe that we're on the verge of a scientific revolution right now with the internet, pretty much of the same scale as the one we've had when the book printing was invented, right? Because right now, you don't have to go to all these institutions, you don't have to be a professor or whoever else to publish your paper in all these major journals, because, well, if your idea is like harmful to the community in the sense that it contradicts many other ideas in this community, you wouldn't be allowed in there, right? Your papers wouldn't be published, your books would be banned, and so on and so forth. But with the internet, you can do that right now. And I believe that the analogy is really strong here, like with the book printing, like when church had the monopoly on knowledge, and with the internet where, you know, the academic institutions previously had the monopoly on knowledge, but they don't anymore. Like, people can organize like what is called citizen science. They can organize alternative cells of, you know, with different theories and so on and so forth. And it's really beautiful, in my opinion. The only thing we lack so far is the way to perhaps sort of organize it in a more civil manner, I guess, in a more kind of precise manner, maybe. Like, you know, all these YouTube channels about the alternative science doesn't feel like the right way of doing that, although I'm not opposing them not in any way possible. Like, I think this is the way forward. It's just that we haven't yet figured out how to arrange that more properly. That's my point. So yeah, I really think that we're on the verge of something really important right here. And the last seventh lesson it's probably kind of too hardcore, so it's more like PS, not BS, PS. For example, Einstein and Infield, in their book, the name of which I don't remember and don't even know probably, they write that one interesting idea, at least is that if you think about it like more in a more general sense, then you would come to the conclusion that really Ptolemaic system and Copernican system are not fundamentally different. Like, it's, you know, everything is relative, so to speak. So you can use either one of these, whichever you like, basically. The thing is that you would have to rearrange, like, the laws of physics, other things, like, you know, with these rotational frames of reference and so on and so forth. But fundamentally, there's no difference between them. That's the important point. And I believe that's a really strong thing, you know, like, many, for example, supporters of various alternative science hypotheses and things like that, they have this firm belief that, you know, my theory is right, you know, this mainstream science is wrong, and so on. I so much hate this, this whole name mainstream science. It's just, but we'll talk about that sometime later. I think I'll make a video about what is called pseudoscience sometime soon, and we'll kind of analyze this in more detail. But so far, what I wanted to say is that basically those people who are fighting against evil mainstream science, which is dogmatic and oppressive and such, basically what they want to do, the only thing they really want to do is substitute, you know, this mainstream science with their own science. Like, they just want to be the leaders, but they want to be the dictators, just like these mainstream scientists are. Really, there's no real difference between them, in my opinion, no fundamental difference. But what this idea of fundamental equivalence of Copernican and Ptolemaic system means is that, well, it's basically, it you know, ruins this hierarchical structure of science where you have the right idea and like wrong ideas somewhere down below. It actually says that you have different ideas, and sometimes they might even contradict each other directly and so on, but they might coexist, you know, and they might more or less, with equal success, describe the same phenomena of the world. And that's a really solid statement, but it's really hardcore. Like you have to be a little bit sick, like me, probably, to more or less agree with that. But I don't know. Well, anyway, thank you for watching. Those were the 7 lessons from Copernican revolution. I hope you had at least a little bit of fun here. See you later, I guess. The eons are closing.